There we go. All right. Oh, you can't see anything. That's better. Yeah. All right. Any questions on the stuff we've gone over so far?
I just have a quick question.
Sure.
You know how you said on Alex that it shows all the videos for every one of your classes?
It's on my. It's not in Alex.
Oh, okay.
It's on my website.
Oh,
Baker's Math Class.
bakersmath.com.
Yep. Yep.
Oh, okay.
And you'll see college algebra. Just click on that, and you'll see the
Yeah,
videos.
so I was thinking you wanted to find something.
Yeah. Not a problem. Yep. Bakersmathclass.com. Yeah, there's some videos built into Alex, but she was looking for the ones like I'm recording this class, so you'll see exactly what I'm doing in the class, which is nice. No problem. All right, so we're going to expand on what we talked about on Thursday, where we started looking at solving of equations. We're going to expand past 2 steps. So there's a total of 5 steps for any solving of equations. 5 steps, you can solve any problem that I can give you. I could fill up the entire back wall of this classroom with a problem, which I've done, and it'll take you 5 steps to solve it. All right, step 1. So I'm going to write them down for you. Step 1 is remove parentheses. Okay, so distribute. Slightly different than PEMDAS. Yes, PEMDAS is 5 steps, but this is slightly different than PEMDAS. So step 1 is to remove any parentheses and distribute. Step 2 is combine like terms on each side. That's okay. So that means any letters, put them together on the same side, any numbers, put them together on the side. So after this step, the most you're ever going to have on 2 sides of a linear equation is 2 things. You'll have the letter and a number on both sides after this step. So no matter how big the problem is, after step 2, it'll be no more than 4 parts. Step 3, move variables to one side. No. Technically, every one of these steps you're simplifying as you're doing it.
Yeah, usually always 5 steps.
Nah. All right.
You know?
Step 4. I know. Remove addition and subtraction. That's the last step. Yeah. And then step 5 is remove multiplication and division. And I'm running out of space, so I'm just going to write it that way, and you know what I'm talking about. Okay, so, and those are basically the 2 steps that we did last week on Thursday, was step 4 and step 5.
I just did problem like these.
Yeah. All right. Any questions with the 5 steps? They good? Everybody got them down? Because they're going to disappear in a second. I can put them back, but they're going to disappear so I can actually do the problem. But I'm going to keep repeating these steps numerous times over and over again, so you will not forget them. All right, so let's look at this problem. So we've got 3, 2v minus 9 equals 15. Step 1. Yep, so let's get rid of the parentheses. So I've got 6v minus 27 equals 15. That's step 1. Yeah, so I'm going to go a couple steps before that point, but yes, that's going to be the next thing we're going to do. So step 2 is combine like terms on each side, right? On the left side, I have 16V and 127, so I'm good there. On the right side, I just have the 15, so I'm good. There's nothing I can combine. Some teachers, I will tell you right now, they use that combine step to move things over. Yeah. No. 3, yes. 3 times 2 and 3 times 9.
I think the combined step you're talking about is like when they have like they say 2 variables on the.
Yeah, so if you have 2 x's, that's when I'm talking about combined. That's what I mean by combined. I do. So I've kind of broken up those steps a little bit more than some other teachers do. And this step is just getting everything down so I just have 2 things on both sides. So the next couple steps kind of flow from there. Step 3, move variables to one side. This problem, I only have 1 variable, so I don't have to worry about that. Step 4, now I'm going to do my addition and subtraction, moving it. So now I'm going to get rid of this 27 by adding 27 to both sides. So the 6V comes down, 27 or negative 27 plus 27 is gone. 15 plus 27 is 42. Very good. And now I'm going to remove my multiplication division, which means I'm going to get rid of the 6 by dividing. So V equals 7. The nice thing, why I break up steps 4 and 5 and don't just say it's like doing it in the combining step, is everything up until step 3, like first 3 steps, I don't have to change operations. Step 4 and step 5 are the ones where I'm changing operations and moving things across the equal sign, and that I look at as different than just putting stuff together on the same side. So by splitting it up, because when you're combining them, you're actually doing the operation it says. So if it says 6V plus 5V, you're adding them. We're not changing that sign. Steps 4 and 5, we are having to change that sign. So in this case, the answer is 4. Oh, sorry, 7. Yeah, it's been a long day. So there you go for that one. Any questions on that one? All the problems are just going to get progressively harder through the class. It's literally just multiple step problems today. So we're going to do a bunch of them. All right, so this one, we've got 11. There's, I think, 18 total topics we're doing today. Yeah. 11y minus 3y equals 16. Guess what? Same 5 steps. Every problem, same 5 steps. And actually, just like I was saying last week when we were looking at those 1-step problems, if you get in the habit of just doing the same process, even though it's really easy to do in your head, these problems, if you get in your habit of asking you those 5 steps, normally what happens with these problems is you don't know where to start. And you get lost. It's like, okay, where do I do? Like, if you go back, I'm going to just ask the same 5 steps. First step, do I have parentheses? Yeah. So I don't have to worry about that step, but you ask it. Step 2, combine like terms. Do I have like terms in this problem? On the left side, I do. I have 11y and 3y. So it's 11y minus 3y. 8y. So I have 8y. On the other side, I don't. Yep. And these problems are all going to be the same, so you can put them together. You're not going to have an x and a y. We will later on down the line, but not right now. So I got 11y minus 3y, just put them together. That's the combining like term step. Step 3, move variables to one side. I only have 1 variable. Step 4, do I have any addition and subtraction in this problem? No. Step 5, I have multiplication division, divide by the 8. So y equals 2. Multiply by definition is if there's nothing between the number and the letter, it's assumed to be multiplication. Right. So it's just 8y. So that's assumed to be multiplication. Yep, y is 2. And it makes sense because 8 times 2 is 16. Addition, you're going to see a plus sign between them. Subtraction, you're going to see the minus sign between them. Division, you'll see it typically written as a fraction. Multiplication, unless it's either parentheses or nothing. My goal is to get rid of the stuff by the y. So since the 8th by the y, that's what I want to get rid of. Yeah.
Because you're trying to find one.
Yeah, because 8 divided by 8 is what? 1. But you don't have to write the 1. That's why you don't see the 1. But that's why, yeah. So I got that part there. Okay. All right. All right, let's get longer. Eventually, I'm going to have to start writing smaller. All right, negative 7x minus 8 plus 3x equals 16. Same 5 steps. Do I have any parentheses? Nope. Do I have any like terms? What are they?
Negative 7x.
Yes, negative 7x plus 3x is what?
Negative 4.
Correct. So I've got negative 4x minus 8 equals 16. No, I'm doing exactly what it says. So in this one, hold on, I'll show you.
Well, that's because it's already
No,
negative.
so the reason I'm doing the opposite is because I have a negative 7 and a positive 3, which are different signs. So because they're different signs, I subtract. 7 minus 3 is 4. 7's bigger, so it's negative.
Just imagine like it swapped around 3 minus 7. It'd be
Yeah.
the same scenario.
So I'm not changing it like we do in the last couple steps when we move things over.
So I wouldn't put like minus 3 under.
No.
3 under 3 minus 3.
Correct. That you will not do that. That's actually the reason I separate steps 4 and 5 from steps 1, 2, and 3. You do not ever do that until you get to step 4. And that's the only thing is when you're moving across the equal sign. Because that actually, what you just said, is the #1 common mistake people make with this, is they try to change the sign to put it underneath it. And that is where you're going to mix things up. I will tell you the majority of these problems are going to be whole numbers. The majority, not every one. So if you get some crazy decimal, odds are you messed something up. Go back and look. And that's typically the mistake that people make is they change the sign there.
It's probably right.
It might be. So step 3 is move variables to one side. How many variables do I have? I have 1, so I can't move them. Step 4, addition and subtraction. Do I have any addition and subtraction in this problem? Yeah, the variable is 8. So I want to add this 8. So I'm going to get rid of that. So I'm going to add the 8. Both sides. So negative 4x comes straight down. Negative 8 plus 8 disappears. 16 plus 8 is 24. Last step, get rid of any multiplication and division. So in this case, I'm dividing by a negative 4. So x equals negative 6. Because when you're multiplying and dividing, different signs are always negative. And if you had done it where you said move the negative 3 to negative 10, you'd have got negative 10x equals is 24. Yeah. And 24 divided by 10 is going to give you a decimal. And that's when you said, wait, something could be wrong here. So negative 6. Moving on up to big problems. Negative 3v plus 7 equals negative 9v plus 49. But we're still doing the same 5 steps. Step 1, parentheses. Do I have any? No. Step 2, combining like terms. Is there anything on the left side that I can put together? Nope. Is there anything on the right side I can put together? No. There is stuff I can put together when I go between the two sides, but those two sides I cannot put anything together individually. Right, yeah, so the negative 3v and the 7 I can't put together because one has a v and one doesn't. The negative 9v and the 49 I cannot put together because one has a v and one doesn't. There's an equal sign between them, so I do not move yet. Step 3, now I'm going to start moving. I'm going to move my variable because this problem I do have 2 variables. So my suggestion to you, you do not have to do this. It does not matter. I know some people always want to move to the left. You can do that. I would move whatever the smallest variable is. Okay? Because if you always move the smallest one, your variable will always be positive at the end, and you save yourself a negative sign that has to deal with. So in this problem, I'm going to move the -9 because it's smaller than -3. Okay? So I'm going to add 9v to both sides. So now -3 plus 9 is 6v. Plus 7, that's gone, equals 49. Some people will do both steps at the same time there, move the letter and the number at the same time. I typically don't. Again, the more steps you do at the same time, the more likely you are to make a little mistake. So following through the 4 steps or 5 steps will take care of that. Any questions on how I move the 9v? It's no different than in the next step when I'm doing the addition and subtraction, same process. Okay. So next step, step 4, what addition and subtraction do I have? I'm going to get rid of this. So I'm going to subtract 7 from both sides. Those go disappear, and this is 42. And then divide by the 6. So v is 7. Any questions with that one? Because that was the first one we moved the variables over.
How did you notice that was 9 before?
Like I said, I always pick the smaller one. -9 is smaller than -3. So the nice thing about doing that is it always gets you. Yeah, what's going to happen is, so actually I can do it real quickly. No. This actually is a very nice little thing because normally people always want to move to the left, and this can happen. So I'll do it real quick, because there actually is a very nice little thing when I'm showing you this. I add the 3v to both sides. That's the only step that's going to actually change. So this is 7. Now this is going to be -6v plus 49. I'm going to subtract the 49 now from both sides. Because again, I'm moving away from the v. So I get -42 equals -6v. And now I have to divide by -6 instead of a +6. Okay. There we go. So you still get 7 equals v. But now you have to deal with the negative signs. By always moving the smaller one, you won't have to worry about that. So saves you that little error that you can make. Okay, next step. Now we have all of them. Almost all of them. We can still add one more step. This will only be 4. All right, step 1. Do I have parentheses? Yep, so let's get rid of the parentheses. Redistribute. 34 equals 6v minus 18 minus 8v. Next step. Nope. I'm putting the 6v and the -8v together first, combining like terms. I have -34 equals -2v minus 18. How many variables do I have? I just have 1, so I don't have to worry about step 3. Now I'm going to take care of the 18. So I'm going to add the 18 to both sides. Yeah, so 6v minus 8v. So 8 minus 6 is 2. 8's bigger. 16. Let's see how much big of a mess it makes now.
Pen a little slow.
Yeah, it's the program I'm using. For some reason, it doesn't want to actually do BNS. Fine. I'm just going to go back and use the other one. I was using a different program today, and it wants to be slow. So it's fine. So we're adding the 18 to both sides. 16 equals negative 2v, and then I'm going to divide by the negative 2. So I have 8, negative 8 equals v. What did I screw up? Oh, where did I screw up? Why?
Negative into a positive.
That makes
So
a
you
negative.
multiply a positive.
That's the mistake. It should have been negative 16. Negative 34 plus 18.
I had the radius.
Right, yeah. And most of you probably did because you were literally doing it and not actually following what I wrote on the board, which is awesome.
Trying to get it ahead of you.
It's fine. So this is, as it's funny, some teachers get all pissed off. It's like, oh no, I make mistakes all the time. It happens to all of us. This is where, when you're moving quickly, because I was frustrated and I got out of the other program and it's like, I messed up my signs. Negative 34 plus 18 is a negative 16. So that should have been a negative 16 there. 2 negatives make a positive, so it should have been a positive 8. So you get the answer wrong. You don't get frustrated and say, I can't do this. You figure out where you messed up. Nope. Yes.
When you divide that by 2, positive.
Yeah, because you're dividing by a negative 2. Correct. Yep. That was the mistake I made. No problem. All right. All right, next one. We've got 7y plus 7 equals negative 2y plus 31. All right, so this one, parentheses.
Yep.
So
7y plus 49.
7y plus 49. And then this side just stays the same. We got variables on both sides. They're being nice and always making me move to the left, even though the way I want to do it. So we're going to move which one, the 7 or the negative 2?
The negative.
Yeah, it's smaller, so I'm going to add 2y to both sides. So 9y plus 49 equals 31. I subtract the 49. So 9y equals negative 18. I got my sign right this time. And we divide by 9. So y equals negative 2. So notice it's as much as even last week, it's the same thing over and over and over again. As long as you don't keep looking at these problems as they're constantly different, oh my God, they keep adding more things, oh my God, they keep adding more steps, you're not going to get frustrated with this. It's just like following a recipe, same steps over and over again. It almost becomes monotonous and repetitive and you're bored out of your mind. It's like, Why? Give me something new. But the nice thing is you learn it, and it's like it's you memorize it at that point. So
So is that one a negative? Negative. Number.
no, when you're multiplying and dividing, same signs are positive, different signs are negative. So the negative 18, yeah, it has nothing to do with the 18 or 9 being bigger. It's just one negative sign. In the 31 minus the 49, that does matter when you're adding and subtracting. The negative 18 is negative 18 because the 49 was bigger. So, yeah. No problem. I think we finally got our first 5-step problem. How about that? Which you've all been waiting for. I swear, it's last school year, my school district asked what we wanted for computers because obviously we're going remote. We need to be able to do stuff. And I said, oh, I just want a touchscreen Chromebook. I was being nice. They went out and bought us all Surface Pros, these computers. Absolutely changed the way that I teach. Like being able to physically write with a pen on the actual device, like not just like one of those styluses, an actual, like literally light years different. So I switched school districts, so I had to give back my Surface Pro this year. And literally my first paycheck, I went out and bought a Surface Pro. I'm like, nope, can't do without this one now. So it's like, yeah, no more paper. Honestly, the iPads aren't bad. This is a full Windows computer. So this is a full computer, keyboard, everything else. So it's like, but it has the full touch capability and stuff. It's so nice.
Mine is still huge.
Yeah, it's so nice. If you're used to Apple products, iPad, perfectly an acceptable use for it. Honestly, the iPad works really well. And they have one of those, at least the newer iPads have the pen.
Yeah, and
So, all right, let's go this one. Step 1, parentheses. This time I have 2 sets of parentheses. Oh my God. Let's get rid of them both. So we've got negative 12u plus 9. Plus 9, or is it v or u? U. Doesn't really matter. Those are fine. 6u plus 24. All right, so you get rid of all your parentheses in one step. Step 2, combine like terms. Do I have any like terms on the left side?
Yes.
I do. I have the negative 12u and the 9u. So it's negative 3u plus 9 equals 6u plus 24. So I said after step 2, you should have no more than 4 pieces of information in your problem. 2 on the left, 2 on the right. Which one am I moving in step 3? The negative 3u or the 6u? I'm going to move the negative 3. So I'm going to add 3u. It finally gave me one that I'm not moving to the left. 9 equals 9u plus 24. I combined the 12u and the 9u. So negative 12 plus 9 is negative 3. You'll almost never see me actually write that step out. And that's fine. No, that's totally fine. Just whatever you do, if you can write it underneath, just write the plus 9, just don't change the sign. Or write yourself a little note next to it so you see how it came out. All right, next step. Right, so I'm going to subtract 24. Oh, not in highlighter. So I get negative 15 equals 9u. And then I divide by 9. And I'm going to be a decimal. So I don't think I made a mistake, but I'm going to go back and check my work just to make sure. Negative 12u, 9, 9u, 6, 24. That is negative 3u, 9, 6, 24. Add the 3, that is 9u, that's correct. Yep, I don't look like I made a mistake. So this one does come out to be a fraction. Fractions are not bad. We just have to reduce our fractions. So what can go into both 15 and 9? 3. So this is going to be negative 5 over 3 equals u. And now we'll see if I actually got my answer right. Yay. Yeah, once they start getting into the more complicated ones with numbers on both sides, you typically do see some more fractions put into them. So, but like I said, just go back and check real quick. It's like, it doesn't take that long to go through and make sure you didn't make a sign error somewhere. All right. No, that's wrong. They're making them all fractions now. All right, so we have x over 4 equals x over 5 minus 4. All right, this is the one situation where I'm going to break from the 5 steps. Okay, we're going to make it a 5-step problem, but we want to do something before this to make it easier to do. You're going to multiply the entire problem by its common denominator. Okay, what's the common denominator for this problem? 20. So I'm going to take the whole problem and multiply by 20. And honestly, if you don't mind working with larger numbers, you can literally just multiply the denominators, multiply the whole thing by that. It'll work every time. We'll just simplify it down the end. So what's 20 divided by 4? 5. 5 times x is 5x. 20 divided by 5? 4. 4 times x is 4x. 20 times negative 4? Negative 80. No more fractions. You're going to multiply the whole thing by the common denominator. So in this case, it's 20. Okay. Now, since we made it a common denominator, dividing is typically easier. So we did 20 divided by 4, which is 5, and we multiplied it by the x, which is how I got to 5x. And then I do it to the next one. 20 divided by 5 is 4, times x is 4x. And then 20 times negative 4 is negative 80. Okay? No more fractions. If I can get rid of fractions, or if I can get rid of decimals, I'm going to do that instantaneously first step, and then I'm going to do the problem the same way that I did all the rest of them. Okay? All right. No more parentheses, so I don't have to worry about that. Do I have any like terms to combine? I'm going to do step 3. I'm going to move over in step 3. Yeah. So there's nothing on either side to combine. I do have x's on both sides, so I am going to move my x. So I'm going to move my 4 because the 4x is smaller. So that gives me x equals negative 80. And actually, I'm done. There's nothing else to do in this problem.
It's funny how.
Yep. Yeah. And I think, and that's unfortunately, that's the thing with math, especially when you're looking at algebra stuff like this, especially if you have that math phobia, is that when they throw those little wrinkles in there, it's like oh God, there's no way. It's like, and that's where having basically drilled those rules into your head, it's like, okay, let's go back. What do we got to do? It's like, and the nice thing is fractions, and actually there's going to be one in here with decimals, I'm almost sure of. If we get rid of them first, the problems are different than we've had before.
Right.
So it's like, once we get rid of it, it's simple. It's a regular problem now again. So look for ways to do that. And that's my job, to show you those little ways to do that. So yeah, just multiply by the common denominator, fraction goes away, start the problem over. Me too. I like fractions, don't get me wrong, but if I don't have to work with them going through, I ain't working with them. Yeah. Keep asking. I don't mind. I did. What's 5 minus 4? Great. I don't have to write the 1. That's literally it. It just happened to be this one came out to be done.
So the answer's 1 when you're doing like in that
Yeah, I don't have to write it.
letter instead.
Yep. If it was a -1, you would want to write the -1 because you will have to divide to get rid of the negative sign.
Okay.
But this one came out to be exactly 1, so I don't have to worry about it. All right. More fractions. And now that I showed you tricks, life becomes easy. What's the common denominator? That'll always work. What's 3 times 2 times 5? 3 times 2 is 6. 6 times 5 is 30. So I'm going to multiply the whole thing by 30. Okay? The nice thing about when we're going through and doing the steps, the only thing that might happen if you don't use the least common denominator is at the end you might have to simplify a fraction. That's the only thing that can happen. So I would not spend tons and tons of time trying to think about the best common denominator to use. If you can't come up with it quickly, just multiply them. All right, what's 30 divided by 3? 10. 10 times -5, -50. 30 divided by 2. 15 times -1, -15, u. 30 divided by 5. 6. 6 times -3, -18. No more fractions. When you're trying to multiply a whole number times a fraction, these divide first, then multiply is probably going to be easier for you. Because of why we chose the number.
What is this called in math language? Like at the top, you know, it's just like linear blah, 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 blah. Like some.
This is probably linear equations with fractional coefficients. This is probably linear equations with fractional coefficients. If I had to guess in Alex lingo what the title was, that's probably what it is. It's probably something with fractional coefficients.
A little tough sometimes too.
Yeah, which is why, honestly, like when I'm going through, you can look at the list. The topics that are here are the exact same list that's on my website.
Okay.
So you can literally just go through and pick them right off right after the other. So, but on my website, there's actually a screenshot of the actual topic list in order with all of them, and you can just match them right up with these problems. So that'll solve that problem a little bit for you. Baker's Math Class. Yeah. Everything's, my website makes literally one place all your stuff. And you don't have to log in. Yeah. Yeah, if you don't have to log in or anything, which is nice. All right. Step 2, combine like terms. Do I have any? Yeah. Step 3, move variables to one side. I only have one. Step 4, add the 50. So -15u equals 32. Yeah. And then divide by -15. When you have ones with fractions and stuff, odds are you very well could get fractions. I don't think I can simplify that.
No.
So we're just going to put it in and see what happens. Yay! It redeems myself. I've gotten a couple in a row right. Here's the thing. When you get one wrong, it does put you back. That is absolutely true. However, do not get frustrated and just click explanation. Because if you can look at your work quickly and find the error, you can get that point back. If you hit the explanation, you lose it forever. You basically have to start over. Yeah. Well, yeah, but it's like, but it's still, it makes you do more. So you don't want to do that.
Yeah, if you have like no topics left.
Yeah, it'll find one of the prerequisites that you have to do. All right. Next one. Plus 6/5 equals -2/3. x minus 7 over 3. They just keep adding fractions. All right. Common denominator. Right. 3 and 5 is 15. So let's multiply the whole thing by 15. Negative 7 times 15. What's 7 times 10? 70. What's 7 times 5? 35. What's 70 plus 35? Nope. 105.
Oh, 70.
70 plus 35 is 105. It's negative 105 x. It's okay. Calculators work well for those things too. All of them. All of them. 15 times 6/5. No, you're not. No, hold on. The 6/5. So you're going to multiply the 15 times the negative 7. That's correct. 15 times 6 and then divide by 5. Or what you're going to hear me say in a second is I do divide and then multiply because it's a little simpler number. So what's 15 divided by 5? 3. 3 times 6? 18. So plus 18. 15 divided by 3? 5 times negative 2? Negative 10. 15 divided by 3? 5 times negative 7? Negative 35. Okay. I wish teachers taught a lot of things, but
It's a lot easier.
I will tell you, this is the way I've taught it for the past 20 years or plus. Huh?
You only do like
I do pre-calc too. I've done pre-calc, I've done calculus 1, 2, I haven't done 3 yet. I've done discrete math, statistics. Intermediate algebra, I've not. I taught it before. I haven't taught it in a couple of years though. So I'm not sure. Honestly, I don't know my schedule from year to year, so I don't know what I'm going to be doing in the spring. I will teach whatever class they want me to teach. So, because unlike some people, I can teach them all, and it doesn't matter to me. Just give me a class. I enjoy teaching it. All right. So which one are we moving? The 105 or the 10? 105, because the negative 105 is definitely smaller.
Further down on the negative.
Yep. Exactly. So 18 equals 95x minus 35. It doesn't matter. Either way it will work. It's just a sign thing. So I add the 35 to both sides, and this one's definitely come out to be a fraction. 53. And then divide by 95. And I don't think you can divide this one. So I think 53, as far as I know, is prime. Now, I'm almost positive 53 is prime. Because you can't divide by 3, because 5 plus 3 is 8, and 3 doesn't go into 8. So, but those are the things. Like 3, you add the numbers together. So 5 plus 3 is 8. 3 can't go into 8, 3 can't go into 53. If it was 54, 5 plus 4 is 9. 3 can go into 54, or 3 can go into 9. So 3 can go into 54. That's how you can check your 3s. Okay. I hope I'm demystifying fractions for you. Yep. Hoping. Yeah, I got to do this one. I was going to skip the next one, but I definitely got to do this one. Huh? Yeah.
So 95x over 95. Oh, never mind.
That's
I
gone.
lost me for a second.
It's okay. All right. This one's slightly different, and I want to make sure I go over this one. I was hoping just to go on to do a decimal one, but I want to do this topic. Okay, so this one, different from the last ones, this one's got multiple things on top of the fraction. Okay? Guess what? We're doing the same thing. We're still doing a common denominator. The only thing that comes in is right after we do the common denominator, how I'm going to write the problem so that you can see how to actually go through and do it. So what is my common denominator for this one? 35. So I'm going to multiply the whole problem again just by 35. Okay. What's 35 divided by 7? 5. So now I'm going to write this as 5, 8y minus 5. I'm not going to do the multiplication step yet. Okay. What's 35 divided by 5? 7. So 7y minus 5. And then 35 times 5 is 175. Okay. So notice the only difference between this one and the last one is the last one only had one thing on top. So I could do that multiplication quick and easy. This one, there's multiple things left on top, so I don't want to do that step. I want to do that in the next thing and not confuse that because we have to multiply by multiple things, and I don't want you to be confused by it. Now we've just got a problem with parentheses, so we're back to my 5 steps. Yep, exactly. All right, so now we go back to my 5 steps. We distribute. So 5 times 8 is 40y. 5 times negative 5 is negative 25. 7y minus 35 plus 175. The problem that I've seen when people just try to do it in one step is they'll multiply it by the first thing, but they'll forget about multiplying it by the other one. So they would have done the 5 times the 8 and got the 40y, but they would have forgotten to multiply the 5 times the negative 5. And then you get messed up. So by doing it in those 2 steps, I think visually it helps, procedurally it helps. So next step. Yep. Negative 5. No, you're fine. Combine like terms, because I do have 2 like terms over on the right side. So 40y minus 25 equals 7y plus 140. Yep, I'm putting those 2 together. Yep, and the 175 is bigger, so it's positive. Okay, now I'm going to move variables over. Which one am I moving, the 40 or the 7? Yep, so minus 7y. So 33y minus 25 equals 140. Now I'm going to add the 25. So 33y equals 165. Divide by 33. The only problem with these is sometimes you're going to get larger numbers. All right, so 165 and 33. What was the trick about? Well, 33, I know the only ones that can go into that is 3 and 11. So what's the trick about 3? We add up the numbers, right? 1 plus 6 plus 5 is 12, right? Can 3 go into 12? Then 3 can go into 165. Okay, so you can use quickly on your calculator if you want to divide it. This one comes out to be 55, actually. Oh, I should have actually just done it. 55 divided by 11, it's 5. Looking at those 2, it didn't like click that it actually could just be divided, but it actually can. Nope, just put y equals 5. So that's those. I'm just going through real quick to look because I'm running out of time. So word problem, word problem, word problem, word problem, word problem. I think all the rest are word problems. Okay. I do want to do this one though. All right, so negative. X plus 5 plus 5x equals 2x minus 6. All right, step 1. Each equation, choose the statement that describes its solution. These are a little trick. Like the actual process is exactly the same. The answers are going to be weird. So.
You want to get rid of friends.
Yep. So I got negative 3x minus 15 plus 5x equals 2x minus 12. So combine like terms. So I have 2x minus 15 equals 2x minus 12. Negative 3, 5x.
Okay.
So now, well, they're both the same, so it doesn't really matter which one I move. So I got negative 15 equals negative 12. If you get to a step like this, which a lot of these problems will, if the answer that you have there makes no sense, like this, there's no solution. Okay? So negative 15 does not equal negative 12. There's no solution. If the answer came out to be, because the next one's not, if the answer comes out to be that it does make sense, say it was negative 12 equals negative 12. That does work, right? That's all real solutions. Okay? So if you look here, the options, no solution is where this does not make sense. All real solutions is where that does make sense. Negative 12 equals negative 12, or 0 equals 0, or 5 equals 5. Right, which actually I think the next one is. That's why I was looking at it before I went on, because I was going to just use the next one to do it, but I think this one actually comes out to be a real answer. So 2v minus 2 plus 8, 12v minus 4, 2v plus 6 equals 12v minus 4. I know, I'm just going through quick and doing it because we've done a bunch of these already. Plus 4. So 10 equals 10v. So the other option you can have in these problems is where it actually does come out, like this one, where 1 equals v, and that's the middle one. So we actually put the number in there for the answer. Okay? That's fine. I'm also recording it, so you actually can go back later and look at it too. So I want to get at least one of the word problems in before I let you guys go. So no solution doesn't make sense. All solutions, it does work. It makes sense. The middle one is where you have the variable left. So that's just like all the rest of the problems we were doing. Oh, wait. The answer in the second box is incorrect. Huh? Where is? Oh. This is what happens when we rush. 6 times 2 is 12. 6 times negative 4 is not negative 4.
Okay, I don't get it.
So it should be negative 2. And it's on video. Darn it. It's okay. Except I still didn't fix it. Oh, God. It's 30. Last shot. Let's see if I get it right the last shot. Yes. The answer is correct now. All right, let me actually fix this so it actually looks right. All right, add 24 to both sides. And now everybody can watch Mr. Baker messing up numerous times in simple math. There we go. At least I make fun of myself. It's all good.
On the bright side, at least we called it.
Yeah, that's all good. All right, so 3 equals V. That's a better answer. For all those that you actually went ahead and got 3 equals V and goes, wait, something's wrong. And all looked at your work thinking you were wrong. So I said, when you rush, what happens? You make those little mistakes. All right, let's do a word problem one real quick. All right, so I'm gonna make this bigger. All right, the only difference with word problems. Ooh, wow. Let's make that a lot bigger. Okay. At least now you might be able to read it. All right, so it says Kevin rented a truck for 1 day. There was a base fee of $20.95, and there was an average or additional charge of 98 cents per mile for each mile driven. Kevin had to pay $199.31 when he returned the truck. How many miles did he drive the truck?
I remember specifically.
Nice. How'd you get it right?
I don't know.
All right.
I got help from.
Oh, the knowledge check?
Yeah, like I
Gotcha. All right. So when you're doing these problems, once you get the equation, everything that I've just taught you is exactly the same. The trick is getting the equation. So you have to read it. A lot of these problems are going to be based around a multiplication and a division, the y equals mx plus b type format that we've seen.
And where people mess up is when they get the
Yeah, that is actually exactly where most people mess up these problems. So let's look at this problem. It says Kevin had to pay $199.31. That is a total. Okay, so equals $199.31. Okay, now it says there's a base fee and an additional charge. Whenever you see this word for each, that's typically going to be your multiplication step. That's what you're going to multiply by things. Okay, for each or per mile, those type of things, those things are typically your multiplication. So I've got 0.98 times miles. I will also, whenever I'm doing my word problems, I will always use a letter that makes sense for the problem. You do not have to use X. Most of the time, X is not going to help you. And especially when we move into the ones where you have multiple letters to do it in systems, you want to use letters that make sense. So this way, when you get the answer, it's like you can go, oh, that's what I'm talking about. So the 0.98 M, and then I have to add the additional fee of $20.95. And now we're back to our simple problems. Yes, there's decimals. You're going to use a calculator, so they're not the end of the world in this situation. So I'm going to subtract the $20.95 from both sides. And somebody have a calculator real quick that they can do this for me? I'm good, but I'm not that good. 199.31 minus 20.95. What was it? Okay. And now I'm divided by the 0.98, yes. So miles equals 182. Now, one of the nice things about word problems, as everybody hates word problems, but they're realistic. If you get an answer that makes no sense, odds are you screwed up. Yeah, 182. So like if you get a negative answer, you probably messed up somewhere. So it's like, think about those things when you're doing it, okay? So let's go put the answer in. Back to my problem. Maybe. There we go. And it's 182. All right. And we're done for the night.